Okay, as normal, I stole these slides. They're about 5 7 years old. But it's an introduction to Python. And before I get started, I sent a link to download the Python shareware free version right there. So I'm going to go ahead and bring that up. That there. It looks a little bit like Met or Octave when you bring it up. That there. It's just that there. So, but it's the shell, and we can use this to learn the language. It's very similar to the shell that we would run with the, oh, what happened here? That's there. It's very similar to the shell in, on the Raspberry Pi. The reason I'm not doing this with the Raspberry Pi is because I can't record the Raspberry Pi lectures. That's there. And since we don't have the Raspberry Pis to distribute there, you can download this software and run the practice, on your laptops. There, I assume everybody has access to a laptop. Is that a fair assumption, right? That there, most of you have laptops. That there, so it's not a very large program. It doesn't take long to download. That there, and it's just an interpreted that there. So that we could go through and write, basics Python. The syntax is a little different than C, but the same programming techniques still apply. There are some differences in the fact that you don't need the end command on if then else's. The indenting makes a difference because that's how it tells whether or not you're in an if then situation right there. So right there. So, but this is let's see, let's bring this up here. Right there. Facebook. And right there, the microcontroller. Right there. And the presentation I'm going through today, and this is you click on this downloads the file itself directly. I'm going to disregard it. I've already downloaded it, installed it, but right there, it's a relatively, you can see how fast it downloads right there. So it's relatively right there. And I know that some of you have asked to join this group, some of you have not. Right there, but this is the group. It's called Microcontroller and Interfacing January 2017. Right there. That's where I'm going to be placing all the links for various things for this class. So that there, you don't have to ask to be a friend to join it right there or anything. And you can post questions in there for me. Of course, if you post a question for me there, everybody in the class gets to see it. Right there, which is fine because if you've got the question, then I can answer it. The most common thing that you'll see me post there is the links to the videos and any slides, any software links that's there. And of course, I've got a little commentary of how things operate on my, that's my little commentary is, do I need a capitalization form? It's talk about excess paperwork right there. And that's kind of a ping on how things operate in, around both here and, nationally. So that's a little political cartoon that I tend to. Yeah. And I think some of you understand that cartoon, right? It makes sense when you're dealing with, the tax department or JPJ or anywhere else dealing with government, and even the UniKL administration. Right there. So, as I said before, we're going to start this class a little slow until we get the Raspberry Pi boards. So, that's there. But let me just kind of go through here and just kind of spend for the next 45 minutes or so going through these slides that I stole from these three individuals. And of course Google and Caltech and Penn State are big players in the development of Python. So it's an open source general purpose language. And the key thing that there is that it is an open source language that there, so it's free to download. And the version that's with the Raspberry Pi is also the open source. Everything on the Raspberry Pi is open source that there, because it uses Debian Linux that there. It's object oriented, it's procedural and functional, so it does, you can use it in any mode you want. You can write functions, you can write procedures, you can create objects, do almost everything with it. It's really become one of the growing languages in the software world. And some people, it won't replace C, but it's easiest to interface with C++. And if you see that word easy-ish, means that it's not trivial. It's not real easy to interface with C++, but it can be done. That's there. So, great interactive environment. There are, the download, you can go to python.org and download, the book. You can download the documentation, everything you need to know. That's there. Welcome. That's there. That's there. So, again, there are textbooks out there. I'm going to see if I can find one that's of the right level. That's there to put up there. We're not going to dig deep into Python other than how to control the Raspberry Pi with it, but we need to look at at least some examples of how it operates up there. I'm not in PowerPoint. I'm in a PDF reader, so it's a little different. The version that I downloaded is version 3.6, so the syntax is slightly different than these slides right there. You probably want 2.5x, unless you're starting from then, maybe 3.x. The current version is 3.6, so we may as well. I don't know what the current version is on the Raspberry Pi. My guess is it's 3.5 or 3.6 right there, since the version that we'll be using in this class once we get our Pis will be the most current version of Noobs, right, or Debian, so it'll probably be I didn't bring my Pi to check it that there, but my guess is it's a 3 point something or the other. So, right there. Technical, that there, again, the only thing comes pre-installed with Mac OS and Linux, right there. So if you're running Linux on a PC or a Mac, right there, and remember Mac's OS 10 and all of its flavors are based on Linux, right there. Most people aren't aware of that, but Mac OS is a Linux flavor right there. So Windows is different than Linux right there. The rest of the world, other than Windows, runs a version of Linux, and Python comes core right there. So if you have, you may not have to do anything. Otherwise, you download the binaries, and I just showed where you get those from. I put the link on there. It has an interpreter. I'm just going to go through the interpreter a little bit today, right there. But right here. So if you bring it up right there, you can just type %Python right there. It gives you an error. So again, that doesn't work with this version right there. It's supposed to give me the help right there. So help copyright. Let's see if help copyright works. Copyright and help copyright. And that doesn't work either. Okay. Again, as I said, this is a different version than what the slides do, so not all the commands work right there. So you can put in a syntax right there. This does work. I can say 3 times 7 plus 2, and it comes back and says it's 27. So it's a little bit like MATLAB or Octave in terms of you've got the interpreted mode right there. To exit, you can hit Control D, which does work. I would not have been surprised if it didn't work. You should be able to also just type exit No. Exit. Right there. Right there. So exit does work as well. Only you got to put the parentheses on it. That there. And one of the things that you'll notice between these slides and the current version is that you have to put things in parentheses where the slides don't show that there. Right there. Python file names right there. If you create a file, you can just type Python in the name of the file. The extension for Python programs is .py. Later we'll go through and how we would write a right there. So you can make a executable and add the following after to make it runnable. We won't do that today right there. So a large collection, you can go to this website right here and that's old enough to not have that available. That's what I get for right there. They probably moved it somewhere else right there. So, and I'll find where it's moved. We won't worry so much about that. We will be running some of the ones that are pre-written for the Raspberry Pi. So if you go to raspberrypi.org, you'll find a lot of example programs. And once we get our Pis, we'll run it on that there. Right there. So it offers MATLAB-ish capabilities. It does do array processing right there. And we don't know if this tutorial is still up and running, but we'll, and sure enough, it does seem to right there. And scientificpython.org, and again, I'm not going to get into that because we're not going to be doing a lot of number crunching with Python here. And also, the version of Python that's available for the Raspberry Pi may not have these libraries. I have not tested that there. You know, obviously, a desktop version of Python has a lot more memory, has a lot more disk space. You know, we're limited on our Raspberry Pi to about 4 gig is what's the entire Debian operating system is. It's under 4 gig right there, because Knobs is under 4 gigs right there. So and that includes Python right there. So the version of Python that is on the Raspberry Pi is a limited version of Python right there. So that there, and again, this allows you to download the MATLAB type libraries, and hopefully it comes up right there. And as I said earlier, I'm not an expert on Python. I know exactly 2 hours more than you do. That there. In other words, I spent a couple hours over the weekend right there. So NumPython is actually the numerical package that you have to install to do the MATLAB type things with it there. It's again, it's open source right there, but it allows there. It does also allow the tools for integrating into C++. It does use the Fourier transform, random number generation. So if you're going to do numerical processing or scientific processing with Python, you would want to add the numerical Python libraries to it. Again, I have not tried doing that with the Raspberry Pi version right there. It may or may not be able to handle it right there. So, okay. Oh, again, right there. It also does plotting if you download the MATLAB plot versions right there. So, you know, in other words, the language is a complete language that's there that incorporates a lot of the advantages of C++ and MATLAB and BASIC. So it's a very powerful language for desktop computers, and it's used for a lot of desktop computing applications today. So that's there. It is one of the fastest growing. It's also used in the embedded Linux world as well. So it is a replacement in some ways that people are seeing possibly for C++ down the road. Will it replace C++ in the embedded world? I don't know, but it has in the embedded Linux world. It tends to be a very dominant language. That's there. And part of what we're doing this semester is actually learning something new just to flex your mental muscles, that the language that you learned when you took C programming in MATLAB is not the language you may be using 5 years from now. The language that you use in the microprocessor course is not the language you're doing that there. So programming is not about a particular language right there. So that there, just as you learn Malay in primary and secondary school and you get to university, you're forced to use English, right? And it's a challenge for some of you that there, especially when it comes to writing original documentation, those types of things, or understanding a professor that doesn't speak Malay that there. So, but again, English is a valuable language from the engineering standpoint, that 90% of all technical journals and books are written in English. That there. And if you're in the embedded world, English is an important language, because languages such as C, C++, Python, Visual Basic are written as English as their core source right there. So English is an important language that they're. So as we look at that there, again, I'm not going to that there. FITS.io, I don't know anything about this particular one other than this particular one allows you to do some image processing predominantly right there. So I don't know anything about DS9 right there. So it's an area that I'm not familiar with. Astronomical packages, if you're an astronomer, there's packages out there that interface with Python. There's custom right there for the engineering development for numerical analysis and other mathematical processes. These again are various versions of Python that are available for special purposes right there. If you go to Python XY right there, what you'll find again is a roofing guide, getting the perfect roof. Well, that's an interesting one. That's not that there. There's a Python library on how to design roofs right there. Roofing materials right there. That takes us to something completely different. So again, a lot of these links are not current right there, because it's supposed to take you to a version of Python that does engineering calculations. Again, the Newbie is probably the best one. That's the most commonly used right there. That there, along with MATLAB plot right there, and that comes from source right there, and that's our 2D plotting library right there. So the key thing to point out is that unlike C for the 8051, there's all kinds of add-ons for MATLAB, and most of these will probably work with the Raspberry Pi because it's the complete library right there. I haven't tested them. Once we get our Pis, we'll test a few of them. So it's not there. Right there. So bits there. Extra astronomy links right there. The basics, again, right there. You can, a comment is with the number sign right there, and we can go through here and we can just simply say right here, and I'm just going to bring this over here to where I can see this right here, and I can say x is equal to 34 minus 23. Nothing happens. Y is equal to hello. Right there. Z is equal to 3.45 right there. I could put an if then, if z is equal 3.45 or y is equal to, notice the 2 right there, hello. Right there. I put the right there. I can say x is equal to x plus 1. Y is equal to y plus hello world. Right there. There plus world. The hello is already there. And I need to put a space in front of that, otherwise I'll run the words together. Right here, I can put a number sign, wherever my number sign is on my keyboard right here. Adding 2 strings, right there, comma, and print X. Now, you need to put parentheses on that right there. X is 12, print Y, hello world, and it operates there. If you don't put the parentheses print X, it gives you an error right there. So version 3 point whatever added the need for, because print is a function call and expects the parameters passed that there. Previously in version 2, print was built into the library, so they made that a function call to make it more versatile. That's a relatively simple way of just how we would do our there. Notice our if then that I didn't put an end there. That there. The end is not needed right there. So again, the assignment uses the single equal, the comparison uses the double equal, just like C++. Numbers, you're expected plus, minus, divide, multiplication, and string formation. That's there. So logical word that there are not that there, so it can use and or not. And again, you can see that I use the word or instead of two. You know, in C I would use 2 pipes right there. So I use the word or right there. In some ways, it's a little easier to read than C right there. So the basic printing command is print, but again, remember that we need parentheses in Python, the new version of Python. You don't have to declare variables like you do in C right there. It figures out what the type is on its own right there. Sometimes it does it correctly, sometimes it might make a mistake. And that's what I understand. I have not ran across it there. Integers are the default. Floats are assigned automatically. You can use single or double quotes when assigning strings. It figures out the different, which one. As those of you remember in C, you can spend half a day changing single quotes with double quotes, because sometimes if you're dealing with binary numbers, they have to be in double quotes. If you're dealing with a 1 or 0 in terms of a Boolean expression, it has to be in single quotes. That's there. It works that there. It can handle a single quote within a that there. So it can handle embedded strings that there. So it's actually more robust in terms of syntax right there. Things that will drive you crazy in C, actually it figures out on its own. So in a lot of ways it's an easier language from a syntax standpoint, that it allows multiple syntaxes to do the same thing right there. White space doesn't mean anything in C or BASIC or most of the other languages. It does mean something in Python right there. So you use a new line will end code right there. If you put the backslash that there, or forward slash, I don't know, is that the back? That's the backslash right there. it will go on to the next line. It will end the line that there. You don't use braces to that there. If you remember in C, you'd always begin a block with a brace and end a block. Here we use the indentation to denote a block. If you go back to this right here, notice that this is indented right here. This indentation. In C, you would put an opening brace here and an ending brace down here. So the braces are needed. It uses the indentation that there. C, the indentation didn't mean anything right there. In Python, the indentation is the equivalent of begin and end. So that is a major difference in the language. To me, that adds a real benefit is that it forces people to put the indentation in. It makes your code much easier to read. It also allows us to do, if then else and indent properly, where in C, I don't know how many times when programs got more complicated, people couldn't figure out which closing bracket begin with what beginning bracket that there. Here, because it uses the indentation, it's much easier to read the code right there. So, right there. And a colon often appears. It's not, that colon is not really needed right there. If I go back to my code here and let me just go back to this line here. Right here, and I go up and I remove this colon. It did not like that. In this particular case, it wants the colon. In this particular case, it wants the colon. Right there. And notice that, the reason I put two worlds in there because it still remember the hello world from the previous time, and then I concatenated another world. If I run this program, particular line again, it'll put world in there 3 times right there. It keeps adding another world to it right there. So, right there. So often the colon appears, it appears that the colon is required. And I go back to what I said at the beginning. Now I'm about 2 hours ahead of you on learning Python, so that's there. It's just that I've learned multiple languages, so I'll probably pick it up quicker than so that's there. Comments start with the number sign right there. It can include documentation string that's there. A lot of times people will not put the comment in that's there. If a line doesn't contain anything, some versions of Python will automatically just interpret it as a comment right there. So, in other words, this is a comment right there. And in this particular case, if I put it inside a quote, it may, or see, it picked up the fact that it was just a comment right there. So it doesn't do anything right there. So evidently this version requires it to be in a quote. This is docstring, this function does blah, blah, blah. In other words, right there. It's probably a good habit to just use the number sign because that defines clearly that the rest of the string is a comment. So you just put a number sign, your comment, the next line a number sign, your comments right there. So this is how we would define a function right there. The function is all inside a indent. It doesn't have a beginning and end right there. the assignment that they're binding a variable right there. Names do not have a strict type, which means that you don't have to begin a name with any particular letter for it to be an integer string or that there. None of you are old enough to remember the old Fortran, but Fortran we used to require that integers started with I, J, K, L, and M, and then floating points started with A, B, C, X, Y, Z, and strings began with other letters that there. We don't have that with Python. We can name them right there. A reference is deleted via that there. We won't get into garbage collection. Garbage collection basically means the variables are deleted right there. So you assign a name just by that there. You don't have to declare. We already mentioned that right there. So that's there. Again, try to access it before it's properly assigned. You'll get an error. So all that means is going back to here. If I put Z in return, oh, Z has been defined right there. Yeah, Z is, we'll say K, and K just simply says that it hasn't been used right there. K has not been assigned right there. So, oh, we're still on here. We can declare X, Y at the same time. This is kind of a neat little trick right there. I can say X, Y equals 5, 6 right there. And that means X is going to be 5 and Y is going to be 6. I can declare 3 variables at the same time and just, just list them right there. So name 1, name 2 equals Iskanda 2 and hack right there. Name 1. And notice that it's case sensitive right there. So when I use name with a capital N, that's, and again, that's the same as C right there. Name 2. Right there. And that doesn't work, but I think if I put a parentheses.
Maybe you can put name 1 plus name 2.
Yeah, I can do this right here. Yeah, that there, yeah. So I can print both names. I was thinking that I could also put a comma in between, but I don't, now that I'm thinking about it, I don't think it'll buy the comma. Yeah, it does. It shows, it'll print both of them in, right there inside of parentheses. So that there. So, and I can do full name equal name 1 plus space plus name 2 and full name right there. So I can do that there. And keep in mind that we're just learning the basic syntax right there. Writing programs, of course, we would write this in a text file and then run it as a program right there. So all these commands will operate within code, but it's like just like you wrote a script in MATLAB. Some of you remember doing that right there. It's the same type of thing as anything we do in the interactive mode, we can do in our program mode right there. So, there. Naming rules right there. Names are case sensitive, cannot start with a number. They can contain letters, numbers, and underscores right there. There are some keywords and or assert right there. That's just a partial list of keywords right there. If, import. Anything that's a command in Python can't be used right there. So you can start a variable name with an underscore. Now, typically, most variables within a function inside the library use underscores at the beginning. Normally, as a programmer, you would never begin a variable with an underscore. That's usually reserved for library functions to define internal variables within the library. And the reason they do that is so that you don't overwrite library variables. So if you start using underscores to begin variable names, you run the risk of overwriting variables defined in the libraries. So you should avoid using, variables such as underscore Bob, underscore 2, underscore Bob. Bob underscore 2 is okay. Bob, lowercase o, uppercase b is okay. Bob is okay. Bob with that there. But these two here I would avoid, and I don't know if I can highlight. Those two I would avoid simply because you run into the problem that they could be used in the library. I don't think Bob and to Bob is used, but sine, cosine, for example, would be that there. I don't know how much we'll get into this right here. The title looks more advanced than what I want to get into, but we'll kind of look at that there. But x equals x does make a copy right there. That makes a reference. This actually gets a little bit tricky right there. I was playing with this before class this morning. That there, if you have a list, it actually references back to the list and not the variable itself. It would say variable, a single variable, that there. And what this is saying right here, and this is kind of an interesting note right here. I'll just kind of put it here. Let's say A is equal to 1, 2, 3. That's a list right there. So if I do A, it lists 1, 2, 3. If I do, A bracket 3, I think, or 2, that's the number 3. So this is A0, A1, A2. Yeah, it starts the arrays. So this generates an array of 3 variables. So if I say B is equal to A, right there, and if I say B, it gives me 1, 2, 3. Now if I append, and I add the number 4 to it, right there. So I print A, that's 1, 2, 3, 4, right? I appended A to the list. If I do B, it also does 1, 2, 3, 4, because B actually just points to the same list. And that's a very, very tricky thing, because that can create some real headaches for you if you're not aware that that's what happens. A and B are actually pointing to the same location in memory. So when I appended A, I also appended B. So that's what this section talks about. And that's a big difference between Python and C, that there. And that can get you into trouble right there. So that's why they're talking about A references the list A1, 2, 3, B references what A references. In other words, B actually points to the same list. It doesn't create a new list called B right there. It just points to the same list. And where did I put my glasses? There's my glasses right there. I'm sorry, folks. I tend to lose glasses, and when I look around at their, every now and then I want to see people's faces to see whether or not they're smiling or whether or not they're giving me that look of blank. Is that the... No, in Malaysia they use the blur look, right? When someone looks blur, means that they aren't understanding what I'm talking about. That they're, in the U.S. we use the word blank, right there. Give me a blank stare, which means that you're in Malaysian English. It's you look blur, that there. So I'm just looking to see whether I got blur looks that there. So, but why? Right there, there's a lot going on that there. when we say x is equal to 3, right there. So if we do this with a reference, we'll say x is equal to 3, that creates a variable called x. And if we say y is equal to 3, and we say y is 3, if we say x is equal to 2, and we hit y, it's still 3. That's a single variable. So that doesn't happen with a single variable. But if we say x is equal to 1, 2, or 1, 3, 4, right there, and we say y is equal to x, and we say y, and then we say x is equal to 1, 3, 4, 1, 2, 3, y is still 1, 3, 4 because I created a new version of A.
That's y equal to x.
Yeah, well, y is equal to x the first time, right there, and it pointed to the original, but then see, this is where things get very confusing, right there, is that the first time I said x is equal to 1, 3, 4, and I said y is equal to x, right there, right there. But then when I did a new version of x, it didn't point, the pointer didn't follow. But when I did y is equal to x, and if I did x dot append 5 right there, now if I do y, the 5 has been, so when I use the append, it keeps the original list and just appends. If I created a new list, then it doesn't follow. That's why it gets very tricky when you're dealing with assigning arrays equal to arrays. And it's just a thing you just got to be aware of. If I created a new array, it didn't follow. So if I said here, for example, x is equal to 1, 2, 6, 9, right there, here's x, and if I did y, it still follows the original. It didn't follow that there. If I did x, or y is equal to x, right there, and I did y, and now if I do a x dot append, and I add 10 to it, and I did y, now the 10 followed. The append means that, it keeps the same list and just appends to it. When I did the new version of x, it doesn't carry that over. And this is actually what I spent about half the morning trying to figure out when this happens, when it doesn't happen there. And it's a huge problem right there. So the only thing to say is we're not going to be transferring in our code, we're not going to be doing much with arrays, copying arrays, so we won't run into this problem. But it does create some headaches with Python there. And a lot of programmers that are used to using C and Fortran and other languages really struggle with this particular right there. So again, right there. No, right there. Again, with that there, and again, this is, we can increment x, that works the same, x is equal to x plus 1, that works perfectly fine. Remember, this print doesn't work without the parentheses right there. And I put these slides up there so you have access to these slides right there. Right there. When we increment x, what's really happened right there is that it's pulling up x and adding x to 1 to x, so it keeps the same value of reference right there. So that there. So, and this goes through the syntax, what's happening internally. All they're saying here is that we created x, and we said x is equal to 3, right there. Then we say that x is equal to x plus 1. We create a new variable right here, which has now got a value of 4, but then we change x to point to the new variable. So all that's saying. That's why x is now equal to x plus, is now equal to 4, right there. Right there. And then the old 3 is just called garbage. It's now deleted That there, we're no longer pointing to it. It's garbage collected right there. The term garbage collection actually refers to deleting old variables that aren't needed anymore. And a program that does a poor job of garbage collection has what they call memory leaks. It ends up eating more and more of your memory, and then you end up rebooting your computer in order because it gets slower and slower. So poorly written programs that don't collect garbage right there. Oh, somebody has to join the. Right, so, all right. I'll approve it right now because I'll forget it later. That's there. That's there. Yeah, yeah. I will say that my memory sometimes goes fuzzy. Well, you know, as you're trying to learn new languages, new things, certain things aren't important right there. So, that there. This is an assignment that there, this is actually in class. If you'd already had this done, I would tell you to do that right there. And I'll get a bunch of these here in the next couple of minutes right there. Actually, I don't need to approve. You can approve each other. That's there. So, that's there. So, you know, all they're saying here is that this is just a, you know, just an assignment right there. And again, print X, this is just showing that, right there, this is just saying X is equal to 3, Y is equal to X, Y is equal to 4, print X right there, and it's 3. And actually, if you just put X and don't put the word print, it will print X right there. So, you know, it's like MATLAB in that respect right there. You don't need the word print. If you use the word print, then you have to, oh, that's dirt on my screen. Right there. I gotta be careful because this is a touch screen if I, that there. So all they're saying is that this Y equals 3 has no bearing on X right there. Now, it's kind of interesting. I haven't tried this, but let me try something here. X is equal to 1, 1, 2, 3. Y is equal to X. And let's do a Y append. 4. Right there, and X. See, that also appends a 4 to X as well. Since Y and X are pointing to the same list, if I append X dot append 5 right there, X dot append 5 right there, and I do Y, it adds a 5. If I do X, it adds a 5. If I do a Y dot append 6, it also adds it to X. So that's why I was saying you got to be very careful. Both X and Y are pointing to the same list. So whatever I do to X, I'm also doing to Y, and whatever I do to Y, I'm also doing to X. Right there. So that goes back to that problem when you deal with, you know, two different pointers to the same list. Right there. That there. So again, this just simply says that again we're right there. So when we do the Y equals 4, that creates a new variable in there. Right there. So this just goes through the same assignment right there. Again, mutable, that there. We change these datas right there. X is some mutable value, and then change Y, and X will be changed. That goes back to the right there. So when we make a change to Y, that there, again, when we say mutable value object, that's that list right there. That's a mutable object right there. And mutable, that there, that's what they're showing is going on right here, is that A is equal to 1, 2, 3, B is equal to A and B are both pointing to the same list. So if I append to A or B, I append to both lists right there, is what's going on right there. And again, surprise, it's changed right there. Again, I also showed that if we append B, we change A as well right there. I think I'm gonna, as I said, I was gonna keep it relatively short because I just wanted to do an introduction today right there. And I created one problem right there. So we're probably gonna slowly pick up Python. What I'd like for you to do between now and Friday, and I'll decide whether or not we'll meet on Friday, that there as Friday gets closer there. What I'd like for you to do is download this version of software right there. And you could actually download it and install it on these machines for that matter, I think. If no, okay, I'll talk to Yati and see if she can install it right there. I'll get that there so that you can follow along. And I'm going to kind of pick up the same approach that I do with my computer programming class. I'll probably do a lecture, and then at the end of the lecture, give you a little program to try right there. You wouldn't turn it in, but the whole idea is that you try it as I do it. You'll remember it better than if you just look at my slides and say, yep, that makes sense, yep, that makes sense. Forcing you to type it in at the end of the hour and trying it makes more sense right there. So tuples, that there is, simple, immutable. Again, strings are pretty much that they're immutable. Immutable means ordered lists of mixed types right there. These are getting into the types of lists that you can and cannot right there. Tuples and strings are immutable, lists are mutable. Now, the word immutable means that they'll create a new copy. Mutable means that you change them in place right there. So, that there. So, again, tuples, lists, strings right there. And we'll talk about that either on Friday or next Monday. We'll get into more of this problem. I don't want to dwell a lot on that there, but these particular slides do because it is a huge difference between the languages right there. It's an advantage once you figure out how to use it. But when you first start using the language, it's a huge pain in the neck right there. So, see, there's a whole bunch of slides that they're mutability. We'll come back on page 43 next time we meet right there. So, right there. I probably only talked about 30 minutes today. Oh, we talked about an hour right there. So, actually, for whatever reason, that hour went quick right there. So, as I said before, my normal lectures are about 50 minutes to an hour and 15 minutes. So